Hi, this is Max Rodersman, and I'm joined together with Richard Crim. And I started this channel, Medium 2. It's now called Writers 2. And Richard came on, and we did a video. And every week, somebody writes me and says, when are you going to do another one of Richard? My first question that I sent him was, he wrote in one of his stories, we will all know soon how much time we have left. And so I asked him if he could explain more about that question, and he sent me some graphics. I'm going to start with that.
Shall we start there?
Is that the graph? Yes.
Yeah, that's the one. Because this is the most important piece of information in the entire world, in everybody's life. What the daily sea surface temperature does next is just, it defines what the rest of your life is going to be. I am amazed that this number is not on the nightly news, on every channel, and in every paper daily in the world, because it's like we all watched, everybody watched the lunar landings because it was significant to everyone. This is significant to everyone. Literally, if this number doesn't start declining or stabilizing, 1 billion people could probably die by the end of 2025. That's how bad this number is. That's how soon we are all going to start feeling the effects of this.
So why aren't we, not that we're not seeing it now, but why, well, are we seeing it now, or what would we start seeing when that happens?
Well, I also, if you look at the daily air temperature, it's also really high. The green line,
chart here, right?
there we go. The green line is the old average for daily air temperatures between 1940 and 2020. Okay, so this is the daily air surface temperature graph, right? And you look at that green line, and that's the average of daily air surface temperatures from 1940 to 2020. And it's a pretty predictable pattern, right? You can see how the year, and this is northern hemisphere, and you can see how you start at the winter and then the spring, and it's gradually heating up into the summer, and then it falls off in the fall, and wham, you're in winter again, and you've got the low point, right? So that's the green line. The two red lines are what a 2 sigma deviation from that average would look like. That would be a hot year or a cold year in a relatively stable climate. 2023, the orange line, was a 6 sigma deviation from the average. Just off the charts bad. 2024 is the black line where the big red arrow's pointing. It's hotter than 2023. 2023 was a 125,000 year record, at least. It was probably more than that, but let's go with 125. 2024, worse. So when you combine this with the sea surface temperature graph, you realize we're looking at something just unprecedented in basically geologic history. Nothing like this has happened since the Chicxulub impact event, the dinosaur killer. The global temperature is not supposed to have discontinuities like this. We started in 2023 at an observable GIS IPCC number of plus 1.2 C over the pre-industrial. And you can argue about that. That's a low ball number, but sure, let's go with it. We jumped from that to 2 C plus 2.0 C in a year, an 0.8 of a C increase in a single year. That's just mind-blowing how bad that is. Now, Hansen predicted that. Let me scroll up. Yeah, you have the other graphic of Hansen's prediction from 2022?
Yes. Hold on. This one?
Yes, that's the one. So Hansen predicted that. You can see, and I talked about that in a number of my last three pieces. Back in 2022, May of 2022, my very second crisis report, I said, hey, the IPCC and the WMO are now forecasting that 2023, we're going to have a massive super El Nino. So everybody knew that the El Nino was coming, right? The question was whether it would be 23 or 24. But the predictions were all the same, that it was depending on who you listen to. Everybody said it's going to be really bad. The IPCC said, oh, we'll get above 1.5 and then we'll drop back. And they're thinking, okay, we're going to drop back to like plus 1.3, right? It'll be a tenth of a degree shift. They were doing a very conservative estimate, and that would put us back into where the green line, which is the Hannah Ritchie, techno-optimist, business as usual line, right? Hansen and I both said, this is going to be really bad. Hansen predicted a 0.6 of a degree peak in the El Nino. I said probably closer to an 0.8, based on the amount of heat that was in the oceans. I think he was being conservative. It turned out to be 0.8 of a degree. Basically, worst case. That's how much off the wall, just unbelievable heat we got last year. Hansen, and again, everybody, IPCC, I'm not generating, wild and crazy stuff. Everybody agreed, including the IPCC and the WMO, that once this El Nino was over, the temperature would drop back some. There was a big question of how much it would drop back, right? They were saying, oh, it's going to drop back a lot. This is going to release all this heat and we're going to be back, and it'll be just a little bit worse than it was in 2022. Hansen said, no, we're going to have, that's that pink line, the little pink dot projected El Nino peak, right. And then you go back into the yellow cone. Hansen said, yeah, we're going to have a big El Nino and then it's going to drop, but it's not going to drop that much. We're going to go back to maybe between plus 1.5 C and plus 1.6 C, something like 0.3 to 0.4 of a baseline shift into a new reality, a new normal, the yellow cone normal, where not only is the temperature shifted dramatically in a single year, we've had a discontinuity, but now we're in an accelerated rate of warming, 0.4 of a degree, somewhere between 4 and 0.5 of a degree per decade, right? So now, and this was what Hansen was saying in 2022. When you look at what the EU and the Copernicus data are reporting for the global temperature in March, they were saying it's March of 2024 was plus 1.68 C over the baseline, right? We went from 2 to 7, 1.2 to 1.7 in a single year, half a degree. That half a degree is equal to all of the warming between 1980 and 2010, compressed down into 1 year. And 1.7 is looking like our new baseline. If you think 1.7 and 0.4 of a degree, somewhere between 4 and 0.5 of a degree per decade, that means 2.0 C by 2030. And that's a conservative. That's me being conservative about that. Okay, go ahead.
Yeah, I was going to say, I think you're even forgetting what you used to say. Maybe I don't remember it correctly. But what I remember is a few years ago, you said they're looking at the global temperatures going up in a linear way, but I think actually it might be exponential. And you laid out the reasons why you thought it might be an exponential rise. And it seems to me that the data is doing what you warned about. You didn't say it would happen, but you said there is enough data that led it to be possible. And if you did hit if you did hit an exponential rise, it would accelerate what the effects to everybody would be.
Oh, absolutely, absolutely, and that was really kind of your question.
Right.
You said, how can we, what was your exact question?
Well, yeah, so my
What
question
might
is
one observe? Can you explain more about that? Not in data, but what might
Right.
one observe? So we looked at the data. This is why,
Right.
this is what's happening for real, not often speculation. This is actually,
Right.
we're living this now. Okay, so I said, I thought about what you said, and I said, if the SST graph is an indication, what happens now is we had this discontinuity, this huge jump because of the declining albedo, right? So we had this huge jump in the amount of heat, the energy that's going into the system, right? And this is very much akin to you walk into
Okay, I'm sorry, Richard. Let me just say, because some of our viewers won't know what you're talking about. Though most of them will know everything. But so, just for your viewers, when he says declining albedo, he means that it's the amount of sun that actually gets through the cloud cover.
Yes,
and gets reflected out
the
into space.
reflectivity of the Earth is
Right.
the more precise way of thinking about it.
Right.
The sun puts out this massive, massive amount of energy, and we're just in the orbit around the sun, and that's what powers everything. The entire climate system is this energy from the sun, right? And so normally 70% of or 30, basically the albedo of the Earth is like 0.29, meaning about 30% of the sunlight is reflected. We absorb the other 70%. It gets into the atmosphere, penetrates down, goes to the surface, and then bounces back, right? And we absorb some of that energy, and a lot of it's bounced back, and then goes out of the atmosphere. So that's the energy coming in. And NASA, which is what I in my last paper, I said NASA has always said a change in the albedo by 1% would double the effect of all the CO2. The albedo is extremely important. Tiny little changes in the reflectivity of the Earth can have huge consequences in terms of heating. We have seen almost a full percentage point decline in the albedo since 2000. And this is not in debate by anybody. This is two separate projects, two separate teams using different methodologies, the NASA Ceres satellites and Project Moonshine, which measured the reflectivity of the Earth from the amount of light that bounced off the moon from the Earth. Both of these projects documented close to a 1% decline in the albedo over the last 20 years.
Well, one of the questions I had, and again, I'm just playing devil's advocate for viewers. So my understanding was, like you said, the oceans are getting really hot. They're storing up this energy. It has to go somewhere. And I think, again, that's what you're often saying is that, it's the problem with the ocean is you can't just, it's not like in the air where it can just reflect away or go away or blow away or anywhere. It's there and it's coming back. So that's correct, right?
Oh yeah, the ocean is this huge heat sponge. It will soak up heat like just until it boils, literally until it boils. The ocean will keep soaking up heat. It's just like boiling water in a pot, right? Except the sun is your heating element, and you're talking about, geologic time, right? Venus once had oceans, we think, and they boiled off.
Right. So the question I have is, as you know, like you discussed in your papers about the sulfur in the fuel for all the tankers in the ocean. So when it had the sulfur, it was decreasing the temperature a bit. So then when I read that the albedo is like 2 times the CO2, in some ways it's it's an argument that says global warming is really bad. But another thing in my head is like, well, if it's 2 times, why can't we just increase the amount of particles in the atmosphere, and then the problem will be gone.
Right. Well, this is you bring up some really interesting points there, because that's Hansen is basic. What you're talking about is solar radiation management, SRM,
Right.
or geoengineering the climate, which is what it really is. And Hansen and myself and a bunch of others, Hansen has been arguing since the early 90s, after the Pinatubo eruption, right? And this gets kind of into the weeds of climate history, but the problem we've always had in climate science, going back to day one, the very first calculation in 1896 by this Swede Arrhenius guy said, warming, doubling the amount of CO2 from 280 to 560 should generate 6 C of warming, right? And the problem is that we never saw that much warming. It never happened. And so this guy Callender Hubert in the 1830s, he looked at it, in the 1930s, he looked at it and he said, we're not seeing that much warming. Maybe it should be 4C instead of 6. He brought it down, right? Scaling it down. And then this British engineer also in like 1938, he did this amazing job. He got all thousands of pages of measurements from all of these weather observation systems across the globe. And, in the age before computers, he by hand tabulated all of that data and did calculations and showed that probably we were looking at somewhere, the actual effect based on what he saw indicated that doubling would only produce somewhere between 2 and 3 C of warming, about half of what the first guy predicted, right? And that conflict has been going on since the 30s, and it splits climate science into 2 factions by the 70s. You have alarmists like Hansen who are saying, I know we're not seeing the warming, but the physics says it's there and that it will happen. So there must be something else that's going on. And there's all this talk in the 70s, 60s, and 70s of, the heat is being absorbed into the oceans and we're just not seeing it. There's like this 30-year delay of how it has the process in the oceans. And so we'll start seeing that heat sometime, we'll see the beginning of the industrial boom in the 50s will start warming us up in the 80s. Which is actually what happened. And that theory got a lot of credence, that 30-year delay. And you still hear people talking about a 30-year delay in terms of CO2 increasing and actual warming. Yeah, that's not true. That was an artifact that was created by the actual real thing that we weren't accounting for, which was sulfur dioxide particulates. And so in 1979 at the Woods Hole Climate Summit, that was convened by Carter to try and answer this question, because they really wanted to know. Carter really pushed nuclear power. And everybody, after the 3 Mile Island, everybody was, no, we can't do nuclear power. That's just not politically feasible. People will vote against it. Nobody wants that. It's going to have to be oil and gas. And the question is oil and gas really safe? So they had this big climate summit. 3 factions were at the climate summit. The alarmists, Hansen, the moderates, which was Manatee and Weatherall, the guys who did the climate model couple years before, that was a moderate climate model. It said 2 to 3 C of warming. And the oil companies, because the oil companies had the best climate scientists, bar none, the best climate scientists in the world in 1979, all worked for big oil. And so they had a pretty good idea of what was going on. By a 2 to 1 vote, the moderates and the oil companies said, hey, based on what we can observe, Hansen and these guys are wrong. there's something else on in the climate system, which is keeping the temperature down about half of what the physics says it should be. And maybe that's because we live in a living world, right? It's not, the world is more complex than a physical model. There's all these other things, and that actually helps moderate the temperature. Life. Remember the Gaia theory? James Lovelock in the 90s, who said, yes, life is keeping the temperature and buffering and keeping us all in a nice, the Goldilocks zone. Well, they were all wrong. And in 1992, the evidence came in. Pinatubo blew up. And in a single year, that one volcano dropped the global temperature by 0.5 degree. And that persisted over another 2 years. And that was the smoking gun evidence Hansen needed. It's all about the sulfur dioxide particulate. That's what we weren't seeing. It was masking about half of the heat all along. We've been kidding ourselves, lying to ourselves from day one. Hansen wrote a paper the year after Pinatubo saying, this is it. This is this is the evidence. The moderate faction basically told Hansen, go fuck yourself. We don't believe you. And they set this very, very low value on the effect of sulfur particulates. Hansen never got the evidence he needed to prove his claim because in 2004, the satellite, which was when he was head of GIS, he had this satellite built that would actually measure the sulfur particulates and the aerosols in the atmosphere. Yeah, and it failed to detach from the rocket and crashed into the Antarctic Ocean. After he had to retire, mandatory retirement, NASA never built one of those satellites. They built 3 just in case. They launched the second one, and it blew up on deployment. And the third one was mothballed because clearly it had problems, and they were going to rework it. And then during the Trump years, it was scrapped. So we actually don't measure the sulfur particulates in the atmosphere at all. We can only infer their influence from other observations on other areas.
So could we, if we just had volcano, I'm a little bit lost here. So let's just say for sake of argument, we could put the amount of sulfur in the atmosphere to reduce the temperature by 0.5 degree. Would that fix the problem, or would that stop global warming?
Oh, well, yeah. Oh, absolutely. We can do this. I mean, no doubt about it. We can, just by changing all the fuel oil back in the ships to be massively, loaded with sulfur. Because we went from 3.5% sulfur down to 0.5%, like an 85% reduction. And that is estimated to, save 20 million lives a year. People whose lives were being cut short because of that pollution around the ports and things.
Right.
So, yeah, let's just, we'll sacrifice 20 million people and get cool down the climate at like 0.5 degree. That's probably a good trade-off. And basically that's what Hansen and every serious person is saying. We have to do that right now. We have to geoengineer the climate with sulfur particulates to bring the temperature down, to buy us the time to do a crash translation off of fossil fuels. And by crash translation, he means building 100,000 nuclear power plants globally by just completely transitioning our climate to nuclear power within, say, 5 to 10 years, or so that we can just completely get off fossil fuels in that time frame. Short of that, we're in deep shit.
But yeah, I don't see either of those things happening.
Well, yeah, that's the gap between what we should be doing and what this is what you get into the problem, the split between techno-optimists and why people like me are doomers. We tell you what needs to be done, right? And then the moderates and the politicians and say, well, we can't do that. That's politically impossible. We just flat out, nobody will vote for that at this point, which is true. But by the time that it becomes obvious that we need to do that, it's too late because things are about to get out of hand. Can you see the 1930s graph of heat wave? The heat wave graph of heat waves? No, heat waves.
Sorry.
Heat wave index. Yes, there we go.
This one?
Yeah, that's no back one. Yeah, let's
Yeah, I didn't understand this one.
let's
yeah,
talk
I'd
about
like
heat
to-
wave index. Right.
Right.
So what's happened is because of the shift in sulfur particulates, right? We've had this massive washout, and that has apparently generated about a 0.5 degree boost in warmth, discontinuity. We jumped into a new normal, right? So the last time this happened was in the 30s, right? We had the Great Depression, and manufacturing and shipping just took a nosedive globally. Sulfur particulates washed out of the atmosphere, and about 3 years later, we started getting heat waves in the U.S. in the Midwest, because when you have a discontinuity, you've got suddenly all this massive heat energy going into the system, and it's like you turned up the thermostat and the furnace kicked in. It takes a little while for the system to process and absorb all that extra energy because 80% of it comes in at the equator. It takes time for that energy to flow from the equator where it starts, and it wants to go, from the hot center to the cold poles. And so it takes time for that energy to flow to the poles. And when you get a discontinuity, part of that seems to be that it builds up really fast in the mid latitudes. Heat stalls out in the mid latitudes. Look at the 30s. The 30s were brutal in terms of heat waves, not record temperatures in the 30s. It wasn't record hot, but it had a record number of heat waves. The heat, it got hot, really hot, not record-breaking hot, but really hot, and then it just stayed there for months and months and months on an end. Like getting 100-degree heat in Texas every day that lasts for 4 months.
Do you think that's what we're going to have now?
Absolutely. That's what this summer is going to be like. That's what the Dust Bowl was all about. The heat came in and it dried out the soils because no rain and nothing but baking heat, and all the moisture baked away and it turned to dust, which is the next graphic. This is the NOAA, NOAA is really conservative. NOAA is like Trumpy science, okay? Of all the weather agencies, they are the one that was most captured during the Trump years by crap scientists. All the good people left, the people who are left are political, basically. So they give you the most conservative answers. And this is what they're forecasting. See that big swath of red across the Midwest? That's a dust bowl. That's 100-degree temperatures for weeks and months on end until everything dries out and blows away. That's the 30s starting all over again. And
It's in California too, so I mean this is showing huge farmland devastation.
Oh yeah,
that's correct.
Absolutely. The California special case because the El Nino charged up they went from, Lake Shasta went from 11% full to 97% full over the last 2 years. Their reservoirs are fully charged up at the moment. So yeah, they're going to have really hot temperatures in the Central Valley, but they're going to be able to mitigate via their banked water for at least for a couple of years anyway. It's, if this persists, then they will go down too, but they'll have a couple of years, which, the grapes of wrath, right? All the people in the Midwest went to California. That, again, that'll hold, but not forever. their water will run out sooner or later.
Well, yeah, I mean, the water tables aren't getting replaced.
That's
very
exactly.
quickly.
You can irrigate, but that has,
Right.
issues of its own, salt buildups, and it's bad for the soil. Irrigation is horrible for the soil because you're building up salts. Over time, that's what brought down the empires of, between the land between the rivers, Babylon and Ur, is that they kept irrigating until it built up so much soil that soil fertility collapsed, and with that goes your empire. Yeah, it's California will hold out for a while, but not for a couple of years, and then we're in trouble, and that's the problem. We're in a new normal. This is the new normal, Max. This is what a 1.7C going to 2C world looks like. The mid the Way back in early days, there was the rhodium group forecasts from the New York Times. Back in Living in Bomb Time 9, where I talked about it, in the end it always came down to food. Yeah, their forecast is basically for Texas and Arizona and up into the Midwest to have months of 100-degree temperatures, during the summer, like 3 months of 100-degree plus non-stop heat. And they said that's at 2C, and they said, that was their worst case 2050, is if we get to 2C by 2050. That's their worst case. And that was 2 years ago or 3 years. That was 3 years ago, 2021, and those numbers came out in the Times. Well, we're hitting their 2050 worst case. Yeah, right now. That's what's happening right now. And that means Dust Bowl. And that a Dust Bowl in the U.S. means crop productivity goes to shit, which wouldn't be the end of the world. We have a lot of excess production. We also have a full year of grains banked, right? We have reserves. So we can, prices will continue to get bad. Food inflation will really continue to get bad, but we'll live. We have, excess capacity. But it's not just us. Argentina is seeing seeing massive production failures this year. Brazil is already, the southern hemisphere numbers are coming in now, and they're seeing production failures. Argentina, Brazil, Australia, India, Indonesia, across the world, people are the numbers are starting to come in, and crop productivity is down, and not down like 5 or 6% around the margins. We're talking like 25 to 40% down across the globe. Food price.
So I mean, so I'm sorry. So is this again getting back to the surface daily sea temperature? So is this related to the droughts and the high temperatures and the farmland? I mean, how is this connected? Or is it not connected?
No, this is connected. This is the heat. This is that 80% of the heat going into the oceans. That's what's driving those temperatures. So what you are literally seeing is, they talk about it now in heroes per second, Hiroshima bombs per second, right?
Yeah, that was a great graph. I have that somewhere.
Yeah, put it in later. Hiroshima bombs per second, right? So
Right.
last year, the average was about 15 Hiroshima bombs per second. Elliot Jacobson and all of us kind of agree on that, right? He's a little more conservative. He splits the difference between the U.S. and the Chinese. And Chinese said 15, the U.S. said 9. He went with 12, split the difference, right? The Chinese are right. The Chinese, the IAP, their Institute of Applied Physics, they said 15 zetajoules went into the ocean, and that's based on the Argo floats, which are 4,000 plus floats that are actually daily measurements of the heat in the oceans, down to 2,000 meters. We know exactly how much heat is going in the oceans. NASA's or GIS and IPCC saying, oh, well, we don't really believe those Argo float measurements. We like our satellite measurements. And then we have this complicated formula based on how warm the surface, right at the surface, we can sort of calculate how much heat goes down to 2,000 meters. And we don't need those actual measurements. We think it's 9 zetajoules went in, and we're going to go with 9. Right? Do you see the disconnect between we think it's 9 because of our satellite measurements and we don't actually have to go and measure, and the Chinese who said, yeah, we got 4,000 Argo floats in the oceans measuring the heat and it's 15. There you go. There's the alarmists who are talking about actual things, and there's the moderates who are defending their old paradigm that they've had. They've been on top in climate science since the 30s. These guys built their whole careers for 40 years. These guys' careers have been based on these models, and reality is telling them, your models are crap. You got it wrong. They're not letting go easy, but we're seeing a moment of paradigm shift in a field of science where one model of reality, the first-gen model, is collapsing in the face of actual observations. And unfortunately for all of us, we're fucked because of that. These guys got it wrong, and they probably killed us. Killed at civilization because they were too fucking stubborn to admit after the 90s that, yeah, we probably got it wrong, Hansen was right. Some of these guys just couldn't bear the thought that Hansen would get a Nobel Prize and be right. So they kept saying, no, there must be something else, there must be something else. And it's now that it's, reality is happening, it's too late. This is, I emphasize, I don't know if you've ever read Kuhn's The Structure of Scientific Revolutions.
Back in college I did.
Yeah, see, this is exactly what Kuhn predicted. And you see this in field after paleontology, archaeology. I mean, you see this in field after field after field. The first generation of theories usually has problems. And they get the public and everybody buys into that, and then it takes a really long time. Usually these guys, first gen guys, have to freaking die before there's a paradigm shift. And that's basically what we're seeing. These guys are dying off and we're having a paradigm shift. They were wrong. Going back, so, if we averaged 15 heroes per second, Hiroshima bombs per second worth of energy going into the climate system in 2023. Look at the graph in 2024, the sea surface temperature. What that graph is telling you is we're averaging a lot more than 15 heroes per second this year. I mean, it could be as high as 20 heroes per second. Last year, 471 million Hiroshima bombs worth of energy went into the oceans, heated the oceans. Look at this year. It's a bigger number this year. And 471 million can sound really abstract. So, like just basically a half a billion. And half a billion is significant because the Chicxulub impact crater, which is the only geological analog that we have to what's happening in the entire planetary history, put in 10 billion heroes in a day when the asteroid impacted the Earth, right? Most of that energy did not go into the oceans because it was a single day impact. There wasn't enough time for them to, it vaporized all the ocean around it, right? Turned it to steam. But the heat didn't have a lot of, most of it goes into the atmosphere, and it flash fried the atmosphere, right? That's why all the dinosaurs, it's like, superheated steam rushed out for thousands of miles and, cooked everything. The blast wave, hundreds of miles leveled. All, flaming debris. The atmosphere literally turns into an oven of like 300-400 degrees, and in the high surface, and cooks things down and sets the entire biosphere gets flash burned and turned to smoke and ash, right? And happens in an instant. But the atmosphere does not hold heat very well. The atmosphere is like It just lets it go. And so the planet cooled really rapidly, and the oceans didn't warm up very much. That's why, nothing bigger than 20 pounds on the surface survived. Everything else went extinct. But in the oceans, almost everything survived. It was a very minor extinction in terms of the oceans because the heat didn't have time to flow out, and the heat dissipated from the atmosphere before the oceans had time to really absorb it down. 10,000 years later, a lush jungle is growing over the impact crater. That's how quickly the plants, the biosphere, plant life recovered. Now, it took millions of years for animal life to re-evolve and fill all the niches. So it was a very stripped down ecosystem for immediately after the impact. You just had plants and insects, basically, and tiny little rodent-sized creatures and birds. But it recovered fairly quickly. By doing it so slowly, we've put in 14 billion heroes into the ocean since the 50s, right? Already we've put in, and 500 million of that was just last year. And we're on track this year to probably put in 600 million, a billion heroes in 2 years. And it's just getting, and this is our new normal. That's what you're seeing here in that graph is the new rate of warming. Our new rate of warming until the Earth energy imbalance shrinks, we're going to stay at a rate of warming of about 0.5 degree per decade. And that means we're going, the sky's the limit. The paleo climate data says 6C. It says way back in 1896, when Arrhenius calculated 6C, yeah, the paleo climate data agrees with him. It looks like 6C at this level of CO2 equivalent.
So he's right eventually.
Yeah, he'll be right eventually. And we're going to find out really soon because we're going to 2 by 2030. And at this rate of warming, we're looking at 3 by 2050. I don't think our civilization can deal with that. Not with the famines. We're talking about famines. We're talking about like 50% population reduction max by 2050. That's how, China has 1.5 years reserves. They bought up half the grain reserves in the world between 2021 and 2022. Between March of 2021, when Xi and Putin had a meeting in Siberia and they signed a moon-based treaty, Xi went home and bought up half the world grain reserves by Christmas. Okay, he bought up so much grain that it spooked the rest of the world, and the head of the U.S. Strategic Resource Reserve came out and said, there is no problem with the global food supply. We don't know what China's doing, but there's no problem. Nobody needs to be worried. He came out and said that in December of 22, right? Then we had 2023, and now we're into 2024, and you look at that graph and you say, yeah, famines are coming. China knew it. They're prepared. They've got 18 months worth of reserves, which is a good thing for them because guess what? Agricultural production just tanked 60% in North China. They're looking at 60% crop failures in northern China this year, which is exactly what happened to them in the 30s. We're looking at Dust Bowl here. We've got grain reserves. We can supply ourselves for a year. Most of the world does not have that capability. And with the loss of Ukraine, the 20 million tons of grain that Ukraine was providing, that's 300 million people for a year. Most of that 300 million people are concentrated in Egypt, Pakistan, and Turkey. All Egypt and Pakistan, not particularly stable places, and Pakistan has nuclear weapons. We're looking at really scary times coming down the road in the next, this year will probably be okay because everybody's going to tap into their reserves, right? Next year, after major crop failures across the world, they're not going to be much in the reserves. It's going to start shrinking dramatically, and that's when famine goes from just being places in Africa that you don't really think about, like Sudan, and you're not really going to go to ever, to places like right next door, Mexico. The U.S. is going to see major hunger because the price of food is going to go. You think it's bad now? Try doubling again, and then doubling again after that. It gets bad really fast when the food supply gets iffy, and that's what's coming.
Yeah, I don't even. I read it a little bit differently. I don't think it's a. I don't think like starvation and famine is going to be a problem because I mean, hey, if I know this is politically incorrect, but if our country is going to send bombs to kill 2 million people, I don't think like we're like we care that that the everybody gets to live in the world.
Oh
I think
yeah,
it's
no, no.
I think it's more of a to me it's more of a thing of the income inequality thing. It's going to be like Soylent Green, which I can't believe how that movie is just it's got it so right on.
Oh
There's only
yeah.
a few people that can
Oh.
afford the strawberry jam, and that's what I see happening. Is that
Well, see, yeah, I know, but then I think, yeah, sure. At first it's inequality, right? And did you ever watch that Earth 2100 documentary thing from ABC that I've touted a few times?
I think I've seen it.
The one where Lucy's born in 2010, and this is her journey through the 21st century, and it's the
Right,
gradual collapse. And then by
right.
21, she's born in Florida, in Miami in 2010. Then they go to California, and then, after the water riots, they take the trip to New York, because New York's the,
Oh,
shiny
I didn't see
gypsy
it,
on
so
the
I'll have to
hill.
watch it.
And then the rest of it is her life in New York, and it deals with like she survives a major plague outbreak and food crisis, and then eventually New York gets washed. They built this gigantic seawall, and it gets breached, and that's what eventually and New York gets flooded, and that's eventually what kills it. And then she winds up on a farm somewhere in upstate New England with her granddaughter, and they're like living a early 19th century life, growing food and whatever. And she survived the 90-year collapse of civilization, basically. That documentary was they had like Jared Diamond, Tainter, all the big names in collapse studies and such contributed to that, so it's really scientifically based. Compress that down, instead of going from 2010 to 2100, that's going to be our 2030 to 2050. We're going to compress all of that. And when you compress that kind of collapse and accelerate it, right? The more you compress it, the faster it has to go. It gets more and more. The faster it goes, the more brutal it gets, right? Because then you're talking not like not a 5% increase in global mortality rates per year over 20 years. You're talking, bursts of huge mortality events, like 10% in a year. 1 billion people die in a year kind of thing. And people don't go down easy. They don't just, oh, yes, for the good of humanity, we have been designated the sacrificial victims, and this zone, we all get to starve, so everyone else gets to live another
Right.
10 years. Yeah, nobody's that altruistic. They're going to migrate. They're going to vote with their feet. The scale of migrations is just, oh my God, we have our head in the sand. We're voting for these policies, right? Although American voters don't really recognize what we're doing. When you look at what we're doing at the global political level of negotiation, we have blocked every effort in the UN to create a human migration agency, or to recognize climate migration. We don't recognize climate migration as a valid reason for leaving your country. Oh, your country's too hot to live in? Screw you. Stay there. We want people to literally die in place so that they don't migrate. And what we are doing is we are offering the elites in these countries, the current governments, we're saying, hey, we'll give you extra supplies and food, and most importantly, we'll arm and train your police forces and your border guards, so not so that you prevent people from coming in, so that you prevent your people from leaving, right? We're going to give extra money to Guatemala so that they can keep their people in and starving, and they don't migrate to Mexico, so then they don't cross Mexico and arrive and hassle us. We're doing that around the world. We are funding governments to restrict migration because we already, we already have a clue that things are starting to get bad. This is not, people aren't going to accept this for very long. They're going, once it starts hitting tens of millions, hundreds of millions of people, governments will start collapsing in food riots and mass crowds of starving people. And once governments start collapsing and you start getting failed state situations like Afghanistan currently is, and Sudan, Ethiopia, a number of other places, once you start getting into failed states, all bets are off. Why would anybody stay there? Hundreds of millions of people on the move. And unlike the 19th century, when 10% of the global population just starved in place, these people have access to planes, trains, and automobiles and boats. They're not going to stay in place. They're going to go to where they think safety is, or where they think food supplies still exist. It's biblical. I mean, we don't have nothing in all of human history has ever equaled the scale of what's about to happen. And people are just still we're not looking at these numbers. We're not looking at this graph. We're still watching Dancing with the Stars. We're still talking about, did Trump pay hush money to, win the last election, to Stormy Daniels, and if it was that illegal. We're still talking about bullshit things when life and death is happening right behind the scenes.
No, I agree with you. And the stuff you talk about, the migration, I mean, that's been going on for 10 years now. This isn't even like a totally new thing.
It's the right? Canary in the coal mine.
Yeah, people haven't connected it. I mean, I think the most interesting thing about the immigration is the number of Chinese people that are now coming up through Mexico and the whatever gap that is. To get to America.
That's really telling too. Our economists read that as, oh, that's a sign that China's economy must be really sucky. Oh, she must be doing a terrible job. That's going to cause him troubles because the economy's sucky. No, you morons. She already has different climate models than the ones you're looking to. And I don't think he believes that Nordhaus guy, the one who said, oh, yes, the future can take care of the future because we'll have this super tech in the future and that'll make dealing with climate change really super cheap. So we must grow at all costs now so that in the future they have the economy they need to take care of all the horrible climate change we left them. Yeah, I don't think she believes that. If you look at his moves from the perspective of what you should be doing in terms of climate change, she has been battening down the hatches, and he's been trying to shed people as rapidly as possible. Suddenly, people can get out of China and just go to Mexico so they can sneak in the U.S. Suddenly, that's possible. China, one of the most restrictive states in the world in terms of giving you visas to get out of the country. You have to be really reliable. They're making it possible for people to leave so that they can, everybody who wants to get out. We want to lighten the load. They know what's coming.
It's interesting. I never even thought of that, but yeah, that makes sense.
He knows what's coming. He's making all of his moves he's pivoting towards an economy that is going to be the China taking care of China over the next 10 years while everybody else, dies and bleeds and collapses. They're going to try and keep the middle kingdom alive.